Okay guys, we're on the last type of problem. We're moving to titration, which we did not make it to in any of our classes, so you should have learned the definition of that, which is the process of slowly reacting a base of unknown concentration with an acid of known concentration, or vice versa, until just enough acid has been added to react with all of the base. And this process determines the concentration of the unknown base or acid. And that was like the slowly adding the drops that the second class was able to do with that experiment to find the exact point when it switches from one to the other. Okay, so that's what we're doing with extra practice problem number 10. Okay, so let's work this together. A chemist needs to determine the concentration of an unlabeled bottle of HBr. She titrates 75.0 milliliters of it with 1.14 molarity of NaOH. It takes 135.0 milliliters of NaOH to reach the endpoint. And what is the concentration of the acid? Okay, so let's first write our equation. Okay, so we have HBr. That's a positive and a negative, okay, plus NaOH. Okay, this is a positive and this is a negative, so everything is working out just fine there. Okay, now we have a hydrogen and we have a hydroxide. This is our base plus ionic acid, okay, acid plus ionic base, sorry. And then we know that creates water plus salt, and that we're going to be left with NaBr. That formula is fine, it's balanced. We look at our equation, okay, and there's only one, it's only going to make one. It is balanced at this point, okay? So let's look at the information that we have, okay? She titrates 75.0 milliliters of the HBr, okay, and I'm just going to write that up here. That helps me to know what I'm doing, so I can look at my stoichiometry and know where I'm going and what I'm doing. She concentrates it with 1.14 molarity of this, okay? Now the question says it takes 135.0 milliliters of NaOH to reach the endpoint. And so what is the concentration of this acid? It's asking you what this is, okay? So here's the question, okay? Now remember, this is not M1V1 equals M2V2 because these are two different formulas. You only use that when it's only one, okay? So just remember that. So let's start off with what do we have and what are we missing? We want to go from here to here. We cannot go in stoichiometry. What do we have to have? We have to have moles. We don't have moles here. We have molarity. We don't have moles, but we can get moles because we have that. Okay, remember our equation that says molarity equals the number of moles of the solute divided by the number of liters of the solution. Okay, well in this example we have this one and we have this one, so we can get this one. Okay, so that's the first thing we have to do. Okay, so you could switch it around or however you want to do it to figure that out. Okay, so I'm going to do that. The thing I'm looking for is the number of moles. So the number of moles is equal to the molarity times the number of liters. Okay, and so I'm going to do 1.14 molarity times, now I have to do liters. 75.0 milliliters will not work. Okay, so if I multiply that out and figure it up, it is going to be, sorry, I gotta find where I wrote it. Okay, 0.0750 liters. Okay, so 0.0750 liters. Okay, and if I multiply that out, now I know that my number of moles is going to be, sorry, I'm looking down at my problem. Okay, 0.154 moles of HBr. Okay, so now what do I do? Okay, so great, I have the moles here. Well, what does that mean? That means now I relate it to the NaOH. That's why we balance, okay? So now we know that 1 mole of HBr relates to 1 mole of NaOH, okay? So that's what I would do here, times 1 mole of NaOH is equal to 1 mole of HBr. Okay, and so my answer is going to equal, I need to get a large one of these at home. Okay, it's going to equal the same thing, 0.154 moles of HBr. Okay, so I'm going to erase this so I can rewrite it over here and keep going with my problem. Okay. Now remember, this is just like that other problem we were doing. It's just saying it in titration. Okay, so we have 0.154 moles of HBr. Okay, so now I know how many moles I have. Now what's the question? The question says, what is the molarity of this one? Well, can I figure it out? Sure. Okay, first thing we're going to have to do though, remember molarity is number of moles per number of liters. We have the number of moles now, but this is in milliliters. We'll have to change it. Okay, and if we change it, it's going to be 0.135 liters. Okay, so let's go put this down here. 0.135 liters. That's what the molarity will be, and the answer is, and we only need 3 significant figures, 2.05 molarity, and there's your answer. Okay, I also could do number 11. If anyone needs me to do that, let me know, and I will do it. If not, I won't. Okay, thanks.